Johnson Space Center, Office of STEM Engagement, and we just got done with Micro-G Next and testing tools all day in the Neutral Buoyancy Laboratory, and they actually close at 4. And so I'm sitting in my car for this information session. And so with that, I'm going to go ahead and keep my camera off. Anisha, you can turn yours on. And Anisha, if you want to go ahead and introduce yourself prior to going into the slides.
Yeah, sure. Hi, I'm Anisha, and I am a communications intern for the Suits Challenge.
Okay, so you can kind of see the agenda, what we're going to go through. We're going to go an overview if you've never been a part of Suits before. If you have been, and this will probably be a little bit the same, but there are some changes and updates due to the pandemic and also to definitely the challenges. We're adding some features that this year that haven't been added before. And so with that, let's go ahead and go to the next slide. So we are one of 6 Artemis challenges that were selected from the Office of STEM Engagement. There are going to be more challenges with that. And so really what we are focused on in every Artemis challenge is to help out the Artemis program and the Artemis missions. And so you've probably heard by 2024, we're going to put the first woman and the next man on the moon. And so our task particularly is in the technical field of informatics and the heads-up display of the helmet of the suit. And so they've been tasked because we're going into deep space. And so we are going to have to become more autonomous with the direction that we're going. And so that means a heads-up display for EVAs is a must. And what you guys would be doing in this is researching the components and giving usability testing to the technical team here at Johnson, just basically things that they're not doing, but they want the research behind it because they're not funded at this moment to be able to do those specific tasks of navigation and some of the science sampling that is going to be with this particular task. Next slide. And so with that, we're going to take you into a website overview. If you went to our website, you probably, on all of the emails that go out, it goes first to a Artemis Student Challenges. You click on NASA Suits, and then you come here and you are able to see the eligibility requirements, the description, and then actually how you propose. And so we're going to go through each one of those today. And if you have questions, please ask those questions. Just go ahead and raise your hand. There's not a lot of us on the phone. You're more than open to open up a mic and turn on your video. That's okay with us. You can put them in the chat window if you don't feel comfortable with doing that, but go ahead and ask those questions because that's what this information session is truly here for, is to answer those so we can get great proposals and hopefully you can be selected this year. Next slide. And so I'm going to turn it over to Anisha.
Okay, yeah. So we can just start with a basic overview of being eligible for the challenge. So one thing to note is that this is a little bit different from previous years due to the current pandemic. So the challenge will be virtual. So you won't be on site for the testing, but your teams can be larger than normal with this environment that we're working in. And all these requirements are posted on the website, like Crystal mentioned. But just an overview, you must be 16 years or older and be a full-time undergraduate or graduate student in the US. And like I mentioned earlier, you can have bigger teams. You can also have teams that consist of students from different universities if you want. And you can have additional faculty members helping you and support you on your team. And that's like an overview if you want to check it out further. This is all on the website as well. And yeah, that's it.
So the only thing that I would add to that is that this is a totally virtual year. So what that means is that you will be coding with whatever device that you decide in augmented reality, whether it is an emulator, a HoloLens 1, a HoloLens 2, or a Magic Leap. And so with that, just note that you will be sending your hardware into us. We will pay for the shipping, is to my understanding, we'll pay the shipping to and from. And so with that, it's not a device that is your personal device. Really, what we want you to do is work with your faculty advisor and your institutions to get in a device that is able to be able to send in and test here on site with some of our engineers and scientists at Johnson Space Center in the spring and April. With that being said, I know the devices are very expensive, and so we are going to have insurance on those capabilities too with the FedEx packages. And then if you don't have one at this moment, there are space grants within your states. Those space grants usually have the ability to be able to, if you propose, to be able to give funds to teams for stuff like this. And so that's a great way. Space grant and EPSCoR are great ways to be able to get funding to be able to buy. And note, I know the HoloLens 1 is no longer on the market. We do have Microsoft, we have a Space Act agreement with them, and we do have contacts of potentially getting you a HoloLens 2. And so I know the military is really the only ones right now that has that, but we do have, again, that contact to be able to have some available to the teams that are actually testing and are selected to come on site. And so with that, let's look at the challenge description. So the challenge description over the last 3 years has always had the informatics. And Brandon is raising his hand and I see he's in here. And so I'm going to go ahead and let him speak for just a second before I go over the challenge description, because he is the NASA Suits activity manager. And I know he wants to give a few words prior to me going into the design challenge. Go ahead, Brandon.
It's actually, I just wanted to be clear to make sure that we note that we can put you in contact with Microsoft, but that is still for a purchase of the HoloLens 2. So that would be something you would want to work with your institution and possibly a space grant consortiums or any other industry partners that you find to help fund your project. Thanks.
Thanks, Brandon. And I see Paramita is also on here, and I know she's the technical expert for this. I can explain the challenge description, but she is the one that has written the description. So Paramita, would you like to come on here and tell them about the description this year?
Sure. Hey, everyone. Give me 1 second. I'll turn on my camera. Hi, everyone. I am Paramita. Nice to meet all of the new faces and welcome to the old ones. And yeah, I'm very excited to kind of present some of the work that we're looking to see from you all for next year in FY21. If you will, Crystal, will you go back to the previous slide? And I can kind of talk a little bit more about the mission description. Oh, sorry, Anisha is the one that's running the slides. Do you mind going back to the previous slide, Anisha? Just the one before this.
This is the previous slide.
Will you go to the one with the crew member and the goals and...
Hang on 1 second.
There we go.
Okay. This one?
The one before. Yeah, that's perfect. Okay. Yes, thank you. So again, I know Crystal mentioned a few things about informatics. And for those of you that have been online, I don't know, maybe I could get like a roll call for any new teams this year. I know that I missed the last meeting that we had, but are there quite a few new teams this year? You could chime in with just like an emoji or something in the chat, that would be great. But for the old teams, there were quite a few challenges leading up to this. So in the past, hi, hey, Hiroshi, how's it going? And so in the past, we've had challenges where we've had a task specifically. A lot of these tasks have been dexterity-driven tasks, similar to what we would do in the first year. It was our pilot year. So we had a task board with a set of instructions. The second year, we had a solar panel repair. This past year, we really wanted you guys to focus on rover repair, as well as some, I guess, vaguer concepts around navigation. this year, I think it's really exciting to kind of talk about the navigation piece. So rather than having a specific task, I think, and executing that on your UI, I think the real goal here this year is to understand how we use a display mechanism and interactions that are visual to be able to guide you from different locations. Now, typically in an EVA, I think one of the 3 goals that I've listed here are the 3 goals that NASA is really thinking about. From an agency perspective, let's talk really high level before we get into the nitty gritty of this challenge description. From an agency level, Lunar 2024 was announced in 2019. So that gives us about 5 years to turn around a full mission. And this year, the agency themselves have completed a navigation trade study. So what does that mean? It's a 500-page document from headquarters that has pretty much detailed any sort of navigation solution. Now, for the future of the suit, one of the requirements is that we're going to have to be cohesive with all of these different EVA assets, the lander, a future rover. For the display itself, we're going to have to be visually cohesive with a navigation solution. That's one of the future forward requirements within our display set of requirements. And so what does navigation mean? It's very nebulous and can be used for a number of solutions. In cars today, we use our phones as a navigation guidance system. We use Google Maps. But prior to having Google Maps, what did crew members on Apollo use? So you typically have your bearing and heading. Anyone have any idea of what one of the first navigation systems were? I think a lot of you might be familiar with a compass. So really that's just telling you it's relaying to you a magnetic field in which direction you're going in. And so that in itself is enough to get you from point A to point B. And so if you look in the challenge description, there's these 3 goals, and then there's an Apollo version, and then more of an advanced version of the navigation. And so each of these goals, the technical team is going to be providing you with specific types of data relaying to each of the goal variations. So in variation A, a lot of, for each of these goals, they're very Apollo era type of data, which is wonderful. And it's exciting to see how you could turn that simple data into visually informative data to guide you in a navigation task. 1, to get from point A to point B, 1, to get you back to the lander, and 3, to identify areas and points of interest. Now, so that's pretty much in a nutshell what we're going to be approaching this year. So the data that you're going to get from the suit's technical team, in variation A, there will be very standard rudimentary navigation guidance points, things like heading, bearing, direction that you're going in, distance. For goal 3, we would like to provide you with a topographical view, and you figure out how you want to display and portray areas of interest for science. And so I think these 3 goals are really the pillars of what's important during the EVA. Getting from point A to point B. Similar, unlike Earth, when we are going outside to navigate ourselves, say we're walking down a street full of buildings, we have waypoints. We have Google Maps will today tell you, take a left at this McDonald's. But when you're on a lunar surface, where the only assets on that surface are different rock formations and your lander and your assets that you brought to that site itself, it's really hard to estimate distance. It's really hard to estimate and have waypoints to give you a bearing of where you are. And so I think it's really important to be able to find the perfect solution for navigation and how we visually display this information so that it's not so that it's informative. And And so that's in this nutshell kind of what we're going to be focusing on this year. I would really implore you to take the moment to look at each of these goals and really read about them, and then look at what NASA's put out in terms of documents and papers that define what some of these goals are. Identifying geological points of interest. I think that's a really unique one in that somewhere that you might get some really good information to find a perfect geology navigation solution is to really speak with geologists. How do they do field studies when they go out in the field and search for rock formation and learn about planet Earth? Similarly, we take astronauts and crew members, they take that geology training themselves to conduct on the moon. Our engineers, we also take that similar geology training. So that's some areas that I think would help you. And that really, I think in a nutshell, describes what the navigation task is all about. There's also the EVA system state task. So this piece of the challenge, it's really defining, for those of you in the past that have been involved, the interaction in the airlock. So what does it take to prepare the suit? A lot of you that have competed in the past, the UIA interaction, that's the umbilical assembly that the suit has the umbilical cord that attaches. And so you do some metrics and parameters that you set in the beginning of your EVA. And then you also have airlock responsibilities when you get back into the craft. And so that's kind of describing the EVA system state task. It's really understanding different parameters of your suit, different parameters of the airlock. And so that kind of describes what that task entails. And then you have your science sampling task. So the science sampling task is probably obvious to a lot of you, is associated with goal 3 of the navigation task. And this is really to understand, I think a lot of you last year did a really great job expanding on this, but really being able to show how we would use visual interaction to aid in a science task. So when a geologist takes a field note, there's quite a few there's quite a few parameters that they have to write down about that geology sample. And so last year I think we provided you with some cue cards. Similarly, that's the cue cards the astronauts use during their field training and during our analogs here at NASA to be able to define their rock formations that they collect. And so we'll provide you with those cue cards again this year so that you can create your field note in your UI as you see fit. So in a nutshell, I think that covers everything. If we can go to the next slide, please, Anisha. So this is a slide describing some of the ranges that you could expect to see of the walk back distance from the center point of the rover, of the lander. And so the red lander there in the middle would be most likely your starting point during this analog. And then you'll have different ranges of data. So walking range at 2 kilometers and some assumptions underneath this. This slide was actually presented at NASA's EVA workshop in 2020 by our ConOps developer, EVA ConOps developer, Dave Cohen. So some of you might be familiar with his work. And this is publicly available. If you go to the NASA EVA workshop website, I think this presentation should be online. But if not, I can give you guys provide you guys a link either over here or ask Crystal to send it out here soon. Crystal or Brandon.
Yeah, Paramita, we're going to post it on the website, this recording. So no problem.
Cool. Okay, great.
I'm so glad you're here.
Yeah, I'm glad I could make it today. Okay, so I think with that pretty much describes kind of where we stand today with the challenge description. Crystal, do you have anything else?
That's all I've got. That's great description. I think before you go though, maybe if we have questions on the technical side on these parameters and these goals, now would be a great time for you to turn on your mics, because Paramita, there are several new institutions on this line. I think I only saw 2 that are not. And so there's at least 4, 5, 6 new institutions that are listening in.
Wonderful.
So questions?
Yeah, I'm all ears.
Okay, so Mickey, go ahead. Mickey, if you want to turn on your mic, you're more than welcome to. I see your hand was raised.
Sorry, I forgot that my headphones mute as well. I actually had a question about the slide that we're on right now. How is this going to apply to what we're building? Like, how are we going to use this slide?
Yeah, so this is going to be these, so some of the numbers here you see there's distances. So the walking range, if you are just within walking distance of the lander, it's showing here that the walking range is 2 kilometers. The yellow arrow is showing you the distance from your lander if we were to give you a rover distance. And then there's a distance from the lander if we were to give you a distance for a SEV or a pressurized rover. And so these are just giving you an idea of the range of distance you should expect. And then underneath, there are just general assumptions from the EVA community of, these specific excursion ranges are used to describe the concept of operations of all EVAs at the agency. So Dave gave this presentation to give an understanding of what are the baseline assumptions that NASA is considering when they leave the vehicle. So you can use these assumptions in a number of ways. Perhaps maybe you might have we can zoom in. I don't have very. So one of the notes here under the unpressurized rover range is that the distance must be balanced with the consumables that are remaining. So consumables are very important when you're doing a walk away from your lander or from your airlock. For instance, the suit has a specific amount of oxygen. So typical EVAs are about 8 hours. So that is because your consumables are limited, because you only have about 8 hours of time in your suit before you run out of oxygen. So in order to be able to walk 2 kilometers, you have to understand and have a state of understanding of your consumables with respect to the distance that you're walking away, so that you know how much time it takes to get back to the lander so that you don't run out of consumables. Does this answer your question?
Yes, that answers it perfectly. Thank you so much.
Any more questions? I didn't see any in the chat, and I didn't see any more raised hands. Just so you guys know, both of these photos are in the proposal description on the website. So I would really highly recommend printing that out and really reading that into detail of what they're asking for. Any more questions for Paramita? Well, thank you so much, Paramita. I just saw something come up in the chat. It says, are consumables on EVA a current total, or is there any conception rate math?
Yeah, that's a great question, Keith. So our telemetry stream that we provide the students each year, there's not a direct math associated to the rate of change of the consumable number or the consumable parameter. So it's about 18 parameters that are within this telemetry stream. And so they kind of change at different given random rates. The rate math for those consumables is actually export controlled, so we were not able to provide that to you, but yeah, in short, hopefully that answers your question. So the telemetry stream that we're going to provide you that has about 18 parameters that constantly changes, it does not have a specific rhyme or reason to the math associated to it. You're welcome.
Thank you. Okay, there's some, let's see here. Sarkis, if you want to go ahead and come on and ask your question.
Hello. Hi. Yeah. So when you mentioned telemetry, will you be able to give us what protocols are you using to provide us with that stream, communication protocols that we can incorporate with the project?
Yeah, so the telemetry stream is in JSON format, and it just reads out those parameters on a web server. You could just pull from that. It's just, honestly, we provide you with a URL link, and you can copy paste that into your, if you're using Unity, into your, there's like a specific place to paste that URL in your UI development in Unity, but it's just slipping my mind right now. So yeah, it's JSON format, outputs into like a web server, string
Okay.
of numbers,
Okay.
about
Nice.
18 numbers. Yeah.
Yeah. All right. Yeah, that answers it. Thank you.
Any more questions? Let's look. Doesn't look like any more hands are raised.
Well, I'm online till the end of this meeting, but if you have anything else.
Yeah, and you can type it in the chat window too, because Paramita's on here, so she can go ahead and help with questions there too. So I guess we'll go to the next slide. And sorry again, I can't turn on my camera because I've been in the MBL all today and they kicked me out. Anyways, so now that we've kind of went over the challenge description, let's look at the proposal guidelines. They are due October 21st, and they are consistent of these things that are on the side. There's detailed instructions of what is wanted on the website. So there's the proposal description that you need to print out, and then there's the proposal guidelines you need to print out. And so with that, you're going to have an abstract that's kind of just a summary and overview of your design. You're going to, on the next one, you're going to go ahead and, from an engineering standpoint, show your design requirements that you've placed within your code. And then you're also going to have a concept of operations. This is truly from the user standpoint of how to operate that. And then you will have human in the loop testing, and you'll propose how you're going to do this. This is going to be a little bit harder because of the fact that we are in a pandemic. And so you have to think up some good ideas of how you could test with still being safe. And get that user testing done. There are a project schedule, which is just trying to get you guys to be like NASA. We have milestones that we have to meet. So we have a project schedule. And so we'll give you a timeline of when you need to be able to be ready for your design review and then for testing. And so you'll go ahead and April is going to be the testing dates. March is the design review. So use those dates to make sure you meet your milestones and meet your code up to at least to the design review to make sure that you're ready for it. Budget will be a little bit different this year because you don't have travel. And so really that budget should show what all you're going to be having to have costs for. So that might be mainly your device or anything else that's going to cost you from an operational standpoint during this challenge. Technical references, like Paramita said, go read, search those NASA research papers that are out there on informatics and see what they're doing. And so use that in your papers to come up with your ideas so you can contribute to the research. Lastly is outreach. Outreach is how are you going to take this, what you learn of NASA suits, and display it to your community and at large. So the one thing that we are requesting this year is that all teams are going to write a white paper to turn into either a technical conference to present or get published, a peer-reviewed published paper. And we will have an information session on that later this fall about the conferences that we think are great ones to be able to propose to, and also how to get a peer-reviewed published paper as well. And so that will be your kind of your final report. There are no guidelines for that, and the reason there's no guidelines for that is because each technical paper or conference that you're submitting to has their own references, their own guidelines that they want you to follow, so you're going to follow theirs. And so again, we will have professors that have done this before come on here and talk to you about where great places, technical communities that you can do that. Another component of outreach would be either a traditional media plan, newspapers, TVs, that kind of thing, or social media plan of how you're going to reach other people with what you're doing as well. One more component of outreach would be a K through 12 component where you are taking this coding challenge and trying to write a lesson plan or get with schools, informal education like Boy Scouts or Girl Scouts, Boys and Girls Clubs, museums, and basically explaining what you're doing with the NASA suits and what NASA, the Artemis program is doing with the informatics heads-up displays. And so it's just spreading the word again in a different way to help us out. So let's go ahead and go to the next slide, because I think the evaluations on that slide, actually it'll be the next slide, but we'll stick here. Another component of this challenge is on the proposal is an administrative section. So when you turn in your proposal, you'll turn in your proposal and there's a specific guidelines for number of pages that it can be. These do not count toward those pages. So just so you guys know that. So the letter of intent is one of the things that you'll do prior to the proposal. And that is due September 30th. September 30th. So that's coming up here in 2 weeks. I know we have another information session that it'll be the exact same information session as today. But if you have questions, feel free to join to ask those questions prior to turning in that proposal. So just all you have to do for the letter of intent is go to NASA or email nasa-suits@mail.nasa.gov. And Anisha, if you'll put that in the chat window, nasa-suits@mail.nasa.gov. You'll put the institution name or names, the team lead's name, and the faculty advisor's name, and just state that you plan on participating and turning in a proposal on October 21st. With the proposal, you'll have to have the 3 next bullets. The letter of endorsement is from a department chair or from a vice president or president of your institution. And that's just basically on the school letterhead stating that, yes, you are. We do know that this team is participating in this because we want you guys to get recognized. And that's one of the ways that you can get recognized from your school. Because usually what happens is they take that to your school media and that becomes part of your outreach plan. And then from there, a statement from your faculty advisor. We just need, and this is again in the proposal guidelines, something stating from your advisor that he or she is your advisor and they will be helping you with this challenge and throughout the challenge. The last thing is from NASA Legal, there's a statement of rights. So if Paramita and her team see something that they really like and really feel like is usable, they have the ability to be able to use your design. With that, next slide. Okay, so the evaluation. So we went over the proposal guidelines. So the top part, the abstract, all the way down to the technical references is worth 75% of your score. And then the outreach portion that was talked about a little bit at the very end is 25% of your score. Then it will total up. We will actually come together all as team members and we'll discuss the scores, kind of make comments and go back and forth. And then this year, I believe what we're going to do is we're going to select around 20 to 30 proposals to stay with us until design reviews. And then at design reviews, we'll probably knock it down to about 10 designs that will be shipped to Johnson. And so during that time from when you're selected to be part of the 20 or 30, what you'll have is information sessions from technical experts. You also could have a technical mentor to be able to ask questions to increase and build your design out. And then you'll work closely with the Office of STEM Engagement to get everything finalized and finished for the designer reviews in March. You'll present out to the technical team, and the technical team will then select those top 10 to be tested based on what you show during the design reviews. There is a detailed rubric on the proposal guidelines. So if you print that out at the very end, you can see specifically on the 75% what is for the abstract, what is for each the code ops, each technical section, and then also for the outreach section. Next slide. And so with that, in the chat window, if you'll just go ahead and tell us, this is quiz time, when the letter of intent is due. And just so you guys know, even if maybe you forget to send in a letter of intent, that's okay. You don't have to have it for the proposal, but we like to have it just so we can help you with any questions that you need throughout September 21st or September 30th to October 21st. So I just gave you a hint. And so hopefully you typed it in the chat window. I cannot see. Anisha, can you see that?
Yep, they're correct.
Awesome. Okay.
Nice.
And so I also gave you a hint on the team proposals are due October 21st. And then I don't think I have stated this. So this is kind of a gentle reminder to tell myself when to let you know about this. October 21st to about mid-November is when those technical reviewers score those papers based on that rubric. And so once that is done, once we have our meeting, then by mid-November, probably right before Thanksgiving is when you'll get notified if you're one of those teams that is selected to go into the online community to learn more about NASA suits and get more details on it to be able to create your code and compete for the design reviews. Next slide. And Anisha, I'm going to hand this over to you.
Awesome, thanks. So I thought it would be nice to just kind of end with some of the overarching technical and as well as educational benefits from participating in this challenge. So one thing that is great about it is you can add it to your resume, and it's because it's like a hands-on real world engineering experience with NASA. It's a great thing to build up your resume as well as work with NASA employees and NASA engineers. So as we mentioned earlier, you will be receiving technical feedback from engineers, which is very helpful for your learning experience. And along the way, you can learn a ton about NASA internships and careers if you want to potentially work here in the future. And that serves as a direct pipeline to the NASA workforce as you get to network with people and learn more about what NASA has to offer. And I guess with that, if you guys have any other questions, we can take those now. Or if anyone,
Anisha,
yeah.
We do have an intern on here from, I think it's from Armstrong, if I remember correctly, and I think they emailed us. So it's kind of cool that we already have a NASA intern on here.
Yes, that's awesome.
Looks like maybe Mickey raised their hand again.
Yes. So I was wondering, I have a question about the team. How you said you're allowing the teams to be bigger this year, but what is the specific size of the team?
No size limit due to not traveling. The specific size limit before was because of travel. So the more multidisciplinary and diverse is probably a great thing, just because NASA is really into having a very diverse team. with different knowledge and skills to be able to bring to the table to brainstorm to come up with that big, great idea.
Okay, for sure. And then, so would there be like a team minimum? Like, is there a minimum amount of people you want on the team?
So yes, the minimum is 5 people.
Minimum is 5, okay. And then I had one last question. So from what I'm gathering, so we all do like the letter of intent and the proposals, and then from the proposals, y'all will select who actually gets to build the HMD and send it to NASA?
So we're going to select, we're not going to do total down selection. So say, for instance, we get 50 proposals on proposal day. We're going to do a first down selection to about 20 or 30. We haven't decided that yet because we have to see the proposals to see how well done they are. Mm-hmm. So if there's 30 great proposals, then we're going to keep 30 of them. Okay. If we only see about 20, then we'll probably just keep 20, and we're going to keep that open right now of how many we select. From there, you'll go into an online community called Canvas. It's an online learning management system. We'll have Teams meetings that are monthly where you hear from a technical expert. You'll also be able to get some of that telemetry stream during that time. You'll meet with the technical team. They'll be giving you further information to actually develop and code it. You'll code. All of those teams will code it. And then basically what we're going to do is you're going to give a design review pitch to the technical team in March of what you've coded and what you've come up with. And then there's going to be another down selection of the top 10 teams that will actually get paid to their shipment, their HoloLenses or Magic Leaps to be shipped to Johnson to actually test with Paramita and her team. And then we'll ship them back to you as well. So only 10 in March, but the first down selection to code will be much larger.
Okay, gotcha. Thank you so much.
No problem. So Sarkis, looks like your hand's still raised, and hopefully, I don't know if that's from last time.
Oh, sorry. Yeah, it was from last time.
No problem.
But since I'm online, actually, I had a question in mind. So what are your expectations, realistically speaking? Are you looking for a demonstration of some sort, or a semi-finished product, or a product that you can just easily use and test? I'm not sure where I mean, what the final results should look like. Or maybe if we have any, we can see some samples from previous rounds. That would be great.
So we don't usually give those out, but I will say the proposal is going to be an idea, a brainstorm, and then it's going to go. It's going to grow if you get selected. So give that big idea of what you want to do, okay, or your team. And that's not a demonstration. There might be some CAD pictures is what I've seen, some different pictures of like how the user goes through, and Paramita might be able to talk to this better because I'm not a technical in this field. And so from there, you won't have the telemetry stream. You won't have some of those other things to be able to make the code until you get down selected the first time. And then once that's built, you're really going to be able to give a demonstrative model at that design review of what you have done with the navigation and what you have done with the science goals and the UIA and so forth. And Paramita, jump in.
Yes, absolutely. So, Sarkis, to answer your question, in the early phases, just like Crystal said, really great description there, Crystal. In your proposal, it's exactly what it sounds like. It is your pie in the sky ideas of what you think you could accomplish. What are the unique things about your design? Looking back to the mission description from the goals of the navigation, are you going to be taking more of a traditional Apollo era path
where you use very limited data, but in a very unique and informative way in your UI and present that as your design. Or are you going to have a more Google Maps version of a navigation solution or Waze or whatever you can think of? Don't just limit yourself to some of these today solutions. And then so we'd love to kind of know in your proposal what approach you're taking. Your question specifically was like, what is the level of fidelities at the end of this all? Are you just presenting a demo, or are you presenting, a full product? Well, the most successful teams that we've seen in the past, the mission statement has been to do a task with your hands. The most successful teams are able to have a UI that reads in the telemetry stream and reads in all of those parameters and has that available to the user, while also being able to have non-obtrusive procedures that are walking that person through each of the procedures. When you get on site at JSC, in the past, we've had during the EVA analog or the EVA test, you have a completely new human who's never been introduced to your HoloLens environment or to your Magic Leap environment or what have you, to your headset. You have a completely new user. Some of those users may have never even used AR in the past, who will have to conduct an EVA from start to finish using your design. So most of the teams that get to the top 10 have that full product. Now this year, I think, is going to be even more unique and more real to how we design for actual EVAs. One thing I may not have explained is that my role at NASA is to develop the displays and controls for the XCMU lunar suit. And when I deliver a design, I'm not going to be on the moon testing those designs out with the crew members themselves. And so similarly, what you guys are going to design, the top 10 teams will be sent to JSC. And with those headsets, we're going to have to be able to train the crew member, whoever is train the user onto your environment, use the headset from start to finish to conduct that EVA, to get you from point A to point B, to look at geology points of interest, to get you back to the lander, and to do that science sampling task. And so, as well as the airlock task. So if you could do all 5 of those things successfully, I think that would be the reach goal, the best, most perfect solution. But we understand that this is also a huge learning process. And so we ultimately want this to be a really beneficial for you in terms of learning and expanding your software development skills, expanding your project management skills, your UI, UX design skills, while also learning about the EVA world and what NASA does when they go on a spacewalk. So that, hopefully, does that answer your question, kind of what we're looking for?
Yeah, actually, that explains it a lot clearer. So thank you for all the useful information. Yeah, that's basically the description that I was looking for. Just kind of like a standard, because you can work on something for a few weeks up until a few years. It just depends on how much time you invest in it. So trying to organize, how much time I do need to commit to the project if I'm going to, be in a team and work on it.
And also in your proposal, I think starting early is a really great way to get ahead of how much time you're committing. In your proposal, there's lots of what Crystal was mentioning in terms of like prototyping your designs. You can prototype those designs in Adobe Photoshop. You can Photoshop those designs however you wish, but ideating is a really big phase of the engineering processes that we go through. Ideation, requirements development, concept of operations development. What is this software that you're building? What are the requirements for it? What is a software architecture for it? That's a really big one, I think, that you guys every team that's writing a proposal, if you can start thinking about what types of features you want your software to have, break it up into these 5 tasks, into the 3 goals, and then the airlock and this EVA system state, as well as the science sampling task. Do those things. Look at how engineering, the real world actually solves engineering problems and what those design processes are. Choose a project management style. And so I would just encourage you to really go from start to finish on all of it and execute. So yeah, hopefully that helps.
Yeah, thank you. Thanks a lot.
Great question. Yeah.
The only other question I saw in the chat window was, do you have to have a faculty advisor? And the answer is yes, that is in the eligibility requirements. And again, they're really there not to help you on the team. It's more of a facilitation standpoint, and also being someone to help you with that white paper, someone helping you, guide you with finding funding if you need a HoloLens, that kind of sort of thing.
I also see a question in the chat, Crystal, from Mickey. So if I understand correctly, we are going to be doing these tasks in the HMD, which is similar to VR. If that's correct, are we building the environment in VR or just an AI that leads us through the environment to complete these tasks? That's a good question. I think to give you a better understanding, at NASA, we will have the environment ready for you. We will also be providing you with the data to put into your user interface. What you are responsible for developing is that display that guides the user through the environment. There have been teams in the past that have separate VR components, and they develop their own VR environment to be able to test their displays. That's fine if you want to do that. That's not within the requirements of the mission description. But the meat and potatoes of this is that you are developing the display and designing the user interface and the information that's going to be present to the crew members so that they can interact with that to get through their task. Hopefully that answered it.
Any more questions? Looks like we're good. Don't forget, you can always email us, and we'll pass it on to Paramita and her team if it's a technical question, to the email that's on the screen. And then we'll post this again. We're going to be updating the FAQs and then going ahead and posting this video within hopefully this week. So you guys will have this as you are writing your proposals. And there might be, can the advisor be a technical one who is not faculty? Dee, can you explain a little bit further what that means? Technical one that is not faculty? What role do they have at your institution? And that'll help me be able to, okay. Yes, at our institution, the advisor is someone who is not, who teaches class. They're a technical expert and work in the area. I think that's okay, but I want to make sure. So if you'll email that question to me, I want to make sure from my activity manager, he's okay with that. He's getting his PhD and he had to get off and go to class. So just email me that and I'll email you back the answer tomorrow, but I think it's going to be okay. I just don't want to say something and then, sure, you can, yeah, it's just, everybody's going to see your email. So that's up to you. And remember, oh yeah, I'll have to cut that out. Actually, okay, yeah, can you drop the email? Got it. Perfect. Yeah, don't put your email in the chat just because of the fact that this is recorded. And so the recordings will be posted on the website. So instead of it saying join here on the information session, we'll hyperlink it to where the information sessions are. So any other questions? Anisha, can you type in the website on the message center? Sorry,
Yeah, I got it.
Thank you so much. And then the website will be posted too. Well, it looks like it's almost 5 o'clock. And so if there's no other questions, we'll gonna go ahead and stop, but I'm gonna wait for Anisha to put the website in. And just want to thank you all for joining today. We really look forward to your ideas and your proposals. I know Paramita is really excited. Every year it's great to see the technical team and how they get excited about the students doing the research. And so, and thanks again for Paramita being on here to help explain the technical side a little bit better than the first session. Really appreciate it.
Yeah, absolutely. Always enjoy.
And Kenny, we are going to post the website right there. I think Anisha's getting it right now. How many, and then we've got the website is posted. How many teams do you usually get proposals from? It ranges from year to year, so we're really not apt to saying that. We're not supposed to, but we usually get a healthy amount. There will be a down selection in the first round. This year might be different though, because we think about it, the pandemic and just different parameters. So please propose, because you just never know. We want to see new ideas. Okay, we'll go ahead and end the session. Thank you guys for joining.
Thanks, everyone. Talk to you later.
Thank you.